Hi, my name is Ulada.
I'm Jess.
And I'm Liz.
And we're going to teach you about
Rational functions.
And all of their key parts.
So let's dive into the math world.
Welcome to the math world!
After watching this video, students will be able to identify and graph all key parts of rational functions given its equation as a function of y. Students will be able to determine the domain, asymptotes, removable discontinuities, and x and y intercepts. Here is some vocabulary that you should know. First is the domain. It is the set of x values in which there are real y values. Next is the range. It is the set of y values in which there are real x values. Also, the vertical asymptote. Vertical lines which are not included in the domain of the function. The function approaches them, but then never reaches them. They're found by ensuring the denominator of a function is not equal to 0. Horizontal asymptote. Horizontal lines which are not included in the range of the function. The function approaches them, but never reaches them. They're found by looking at the end behavior of a function. Removable discontinuity. A point not included in the domain of a function, but not an asymptote, a hole in your graph. Degree. This is the largest exponent of a variable, so for x squared, the degree is 2. The degree of a polynomial is the largest exponent of a variable in the equation. X-intercept. Value for x where y equals 0. Y-intercept. Value for y where x equals 0. Today, I'm going to teach you how to determine the key parts of a rational equation. When you see the equation, you can immediately determine the horizontal asymptote. That is the end behavior of the function. You can either substitute infinity into the equation or simply look at the coefficients. This can be done by looking at the degree of the x in the numerator and the denominator, so like the highest exponential power. Let's first assume that the degree of both the numerator and the denominator are the same. If there are coefficients in the front, then the top is divided by the denominator, and that's the value of the y in the horizontal asymptote. If the function is bottom heavy, where the numerator in the rational function has a lower degree than the denominator, then the horizontal asymptote is at 0. If the function is top-heavy, then the asymptote will not be horizontal, but you don't need to know that for now. To continue finding the key parts, you need to factor the numerator and the denominator. This will enable you to cancel out the same factors. Find the domain. It excludes the x values we determined for the vertical asymptote and the holes, but otherwise goes from negative to infinity to positive infinity. In order to find the x and y intercepts, you need to replace the other variable with 0, just as you would for any other type of function. The factors that are canceled out in the denominator will become the x values for your removable discontinuity. That is because the denominator of a fraction cannot equal 0, so these values cannot be part of the domain. However, it is not an asymptote because it can be removed by simplifying the equation. Then, you must substitute this x value into the now simplified equation to find the y value. This point is the hole, or the removable discontinuity. There's another factor left in the denominator, that is the x value for the vertical asymptote. Solve the denominator by setting it equal to 0. This will show you which values cannot be included in the domain, and thus are your asymptote.
I am now going to show you how to apply all of these fine words of math wisdom to an example. It looks scary, but it is actually not. First, we have to find the horizontal asymptote. We will do this by first looking at the highest degree of the polynomial of both the numerator and the denominator. As you can see, the highest degree of each is x squared. Therefore, you divide the coefficients, and 1 divided by 1 equals 1. So the horizontal asymptote is y equals 1. Next, you must factor the equation. Now, it's probably a good time to find the domain. X values cannot exist when the denominator is 0. So, your domain is all real numbers except for -2 and 3. Now, let's go back to our function. As you can see, x minus 3 is on the top, both the top and the bottom of this function. So you can cancel it out. This is a simplified fraction. Find the x and y intercepts. To find the x-intercept, simply substitute x into the simplified fraction. You will get y equals 5/2, so the y-intercept is 0, 5/2. Now, set the equation equal to 0 to find the x-intercepts. You can now do some fancy cross multiplication and find out that x equals -5, so the x-intercept is -5, 0. You can find your hole by taking the removed factor x minus 3, setting it equal to 0, and solving. So the x value for your removable discontinuity is 3. Substitute 3 simplified equation, and you will find that the y value is 8/5. To find the vertical asymptote, take the denominator of the fraction and solve. So x plus 2 equals 0 gives you a vertical asymptote of x equals -2. To graph, you first want to graph the asymptotes using a dotted line. After this, draw an open circle over the point which you have calculated to be the removable discontinuity. Plot your x and y intercepts now, which you have also found. You should now make a table of values using a reasonable domain. For your table, let's just use the values of -5 to 5. And then, just plot all the points and conduct the lines, making sure to go as close to the asymptotes as possible without actually touching them. Good job. You did it.
I will do another example. Let's look at the function. To begin, find the horizontal asymptote. This is y equals -4 because 4 divided by -1 equals -4. And you get those numbers by looking at the coefficients of the highest degree, which is 2 in the x squared. Then factor the numerator and the denominator. And if you do not know how to factor, then go and watch the video on factoring. Then you want to find what x values make the equation in the function undefined. This is when you take the denominator and you set it equal to 0. Then you can find the domain easier. X cannot equal -7 or 4. Because the numerator and the denominator both have x minus 4 as a factor, they can be crossed out. After crossing out the x minus 4 factor, you still have an x minus 4 factor in the numerator because it was squared before. From this equation, the simplified equation, to find the x-intercept, you set x equal to 0, and you will find that it ends up being 16 divided by 7. And for the y-intercept, you then set the equation equal to 0, and find that x then equals 4, x value in the removable discontinuity, because x minus 4 equal to 0, x then equals 4. To find the removable discontinuity, substitute the 4 found before back in for x into the simplified equation, and you will find that it is at 4, 0 because the y value ends up being 0. However, what you find here, because you find that the y-intercept is at 4, 0, and you also know that the removable discontinuity is at 4, 0, this function does not have a y-intercept. One can see that the vertical asymptote has an equation of x equals -7. So hopefully this video is helpful to you, and if you are still having difficulty, hopefully you're able to determine where that is, whether it be with factoring or setting the denominator equal to 0 to find those vertical asymptotes. In which case you can go then on to the channel and watch other videos about factoring, and we have a big plethora of videos for math in which will help you out. So yeah.
Thanks for watching.
Thank you.
We love you.